Hi everyone, welcome to your PlayPosit for the week. We are going to be covering 4.06 and 4.08 in your OMHS, so go ahead and grab your notes and we'll get started. I missed you all last week. I hope you had a great week and we'll definitely catch up in live classes. I wanted to go over the last two slides from our last time together. Many of you did this on your own, but I just wanted to make sure you had the solutions that you needed. We did this one in class, so let's actually go to this one. Actually, wait, no, this was the breakout room one. Okay, so we are going to find the domain and range for this given relation. And this right here is just an XY table, another way to represent a relation or a function. And they want us to list those values. So remember, we always start at the origin. And if we want to find this first red point, we'll go to the left, -3, and up 2. So this coordinate point is -3, 2. Let's try this one, -1, -5. Here we have 1, 6, and 0, 5, and 4, 2. There we go. There's all of our coordinate points. When you look at this relation, is this a function? Is this a function? The answer is yes. Why? Why is this a function? Because the x values do not repeat. So remember, if we had another point here, then we would have -3, -2, and -3, +2. So in this case, the x value is repeating, putting those points right on top of themselves, making it not pass the vertical line test. So that's just an example of how we would not have a function. This one is a function. And the domain, remember, are all the x values. So we could list all the x values. We have -3, -1, 0, 1, and 4. And the range are the y values, -5, 2, 2, 5, and 6. And here they're asking for some function operation. So remember, f of 4, that's how we say that, f of 4. And the value on the inside is the x. Remember, f of x. So this is saying when x is 4, what is y? Remember, f of x is the same thing as y. So we're going to go to the x coordinate when x is 4, and that means y is 2. All right, the second one here, is this a function? If we draw a vertical line anywhere down this, it only crosses the line once, which means there are no repeating x values, so this is a function. What is the domain? So remember, the domain are the x values. And when you have a graph of a line that extends in both directions like this, the domain is I'm going to say a range of numbers. A range meaning an interval, right? The x value starts at some number and then it ends at another number. So if you were to stand here and walk along the x-axis, see like where's the very first x value you come to? Many people might say right about here. You're not wrong, but this arrow indicates that the graph goes on forever and ever in that direction. So really, the first x value we're going to come to is -infinity, because that graph is just going to keep going on forever and ever and ever and ever and ever in both directions. So it's going to start at -infinity and it's going to go to +infinity. And if we're using interval notation, we're going to have parentheses on this, because remember, parentheses means it is not equal to, and brackets means it is equal to. And you can never equal infinity, because infinity is not a number, it's an idea. This is a representation. The infinity is a representation that the number continues forever. So we will never actually equal a number called infinity. So it will always be parentheses. Another way you can write domain is using inequalities. So we could say that x is between -infinity and infinity. This is another way to write this. So it's the same answer, just written a different way. And we only have less than and less than because we're not having equal to, because you can never equal infinity. All right, what is the range? The range are the y values. So as you're looking at this graph, the very first y value we come to is right here, y equals 0. And the graph is filled in there, so it is allowed to equal 0. So we're going to have a bracket. And it goes on until the graph stops in the y direction. And look, the graph never stops in the y direction. So we're going to go to infinity. You can also write it this way, 0. So x is between 0 and infinity, because x is in the middle. And we will have an equal to on the 0, because the 0 is included. Okay, these are fun. Look, f of 2. So 2 is that x value. So when we go to 2 on the graph, what is y? And it is 4. Same here. When x is -1, y is 2. And this last one, we're kind of going in the opposite direction. Now they give us f of x. They give us y. So it's saying y is 2, what is x? So this time we'll go on the y-axis at 2, and look, you actually have two values when y is 2, when x is 1 and -1. So we would have two answers for that. We're going to continue our functions unit by doing some graphing analysis. This is one of those things that I love and I also don't love because in math you'll see and in statistics you can make your graph say lots of things, like whether it was actually true or not. You can adjust like the increments here on the axes. You can just it's so wild what you can make graphs show. So it's really important that we're reading them carefully and we're asking questions. So here's our first one. Fence installation. So the first thing we're going to ask ourselves is, what is this graph even showing? So when you look at this, you see linear feet along the bottom and you see cost along the left-hand side. So the X value is the amount of feet of fencing, and the Y value is how much that costs. So we can kind of just look at it and say, oh, okay, if we have 10 feet, that's going to cost us $300. So fence installation companies actually have charts like this because it's super easy. Oh, and a customer is going to have 20 linear feet of fencing, that's going to be $450. So what is the slope? So we can find the slope just like we have been, rise over run. Just be careful how the increments of the axes are going. So if we rise up here and run here, how far did we actually rise? It looks like every 2 blocks is 50. So every block is 25. So we went 25, 50, 75. We went up 75 and we went over how many units? Be careful, the units on the bottom are different. Units on the bottom go by 5, so we went 5. Of course, this can be reduced, right? How many times does 5 go into 75? And that is 15. Okay, so we found the number, but what does it actually represent in this situation? And sometimes it helps to put the labels up here. So this is like $75 for 5 feet, or $15 per foot. And that kind of just like jumps out at you. Well, it's telling us it's $15 per 1 foot of fencing. Or we could say it's the price per foot is what it represents. Our y-intercept here, that's where it crosses the y-axis, that's 150. And in this case, what do we think that represents? You look, it's above the 0. So at 0 feet of fencing, the customer has to pay $150. So no matter what, if they get 5 feet, 10 feet, 100 feet, their starting cost is $150. So that is our starting cost or starting fee. And a lot of companies have that built in. It just helps them kind of keep their product at a good price for them, right? Because if somebody brings them in to lay 5 feet of fencing, they're only going to get $75. So a lot of times parts and labor can be built into that. So how much will it cost me to fence in my yard of 18 linear feet? So this is basically asking for F of 18. If you go on the x-axis, it's right about here for 18. If you go up, so it's going to be right about here. We don't really have an absolute, like an exact value. So it's between 400 and 425, approximately. We found the per foot cost, right? It was $15. So if you did 15 times 18, that would certainly give you the cost of 18 feet, and you get $270. If you look, we determined, or we estimated it would be around the 420 mark. And that's not 420. So what are we missing? Remember, it's not just 15 per foot, but you also have this $150 starting amount. So you have to account that in for 0 feet and add that into the cost. So this customer is going to pay about $420. And there it is. There's our estimate. It matches beautifully. So don't forget that y-intercept, that starting fee, when you're calculating the cost of something. You know what would be really helpful though for these, especially that last one, is if we had the equation of the line. So you could do that. And we know the equation of the line, right? Y equals mx plus b. We know the slope is 15 and the y-intercept is 150, which is exactly what we did down here, right? You plug in 18 for x and you get the 420. So we kind of did it 2 different ways. We kind of reasoned our way through it, and then here I showed you using the equation of the line. Here's another example. What is this graph even showing? Well, we have an image, so we're like, okay, we're doing something with an electric vehicle for a 4-wheeler. We used to ride these when we were kids. Let's see. I wish I was a better artist on here. Helmet, that's a helmet. So along the x-axis, you see the miles traveled, and the gallons of gas in the tank. So it makes sense that the more you travel, the less gas you're going to have. So our line is going down. So as the x values increase, the y values are decreasing. What is the slope? It looks like we went down 2 and over. Careful. In these real world graphs, you got to look at the increments. We went 10, 20, 30, 40. So it went down 2 and over 40, which is 1 over 20. My computer. So this is gallons per miles. So what does this represent? Remember, this is miles traveled. So it means we're going to use or lose 1 gallon of gas for every 20 miles traveled. 10, 20, 30, 40. Yep. So 1 gallon used per every 20 miles. What is the y-intercept? Our graph is going through 4 on the y-intercept, on the y-axis. 4 gallons. And what does that represent? Remember in our last problem, it represented that starting fee, and then the cost of the fence just went up from there, right? Here, it represents our starting amount of gas. And then, of course, the gas amount just goes down from there because you're using it. So this is the amount of gas in the tank to start with. Amount of starting gas. It's really important to know how much gas you have in the tank of your vehicle, especially if you have a big day planned, because if you don't have enough gas in your tank, you won't be able to continue your journey, right? I do this all the time, and like when in my own car, I'll turn the car on and like, oh, okay, I'm good to go. I have a half a tank. I know I'm about 20 miles from my